Hi everyone, my name is Akash Singh and my enrollment number is E20CC200. Today I am going to discuss a topic called Huffman Coding, and let's begin now.
Hello everyone, I am Akash Singh. I have introduced myself, so no need to again. Let's begin now. What is Huffman coding? Huffman coding is a technique of compressing data to reduce its size without losing any of the details. It was first developed by David Huffman. Huffman coding is generally useful to compress the data in which there are frequently occurring characters. What is the frequently occurring characters? You might not understand, so I am explaining. Frequently occurring characters means a character which repeats itself from more than one time is called frequently occurring characters. For example, myself, Akash. In Akash, A repeats two times, so its frequency is 2. K repeats one time, so its K frequency is only 1. I hope you understood. If you do not understood, God mercy on you. Huffman, while he was a SCD student at MIT and published in the 1952 paper, rest you can read. How Huffman works. It is the working of Huffman. So I hope you will focus here. If you will not, doesn't matter. Each character occupies 8 bits. There are a total of 15 characters in the above string, and you will see there is no above string. So I will show the string in next slide. So don't worry. Thus, a total of 8 into 15 is equal to 120 bits. 120 bits are the size required to send the message before encoding, are required to send the string. Using Huffman coding, we can compress the string to a smaller size. So, total idea behind the Huffman is reducing the size of a string or the message which have to be sent. Huffman coding first create a tree using the frequency of the character and then generates code for each character. This line says Huffman first create a tree like a binary tree, you can say. It creates a tree and from that tree it generates a code for each character. Once the data is encoded means once the tree formed and data for each character forms, it has to be decoded at the receiver side. Decoding is done using the same tree. This says the decoding will be done the tree formed. Huffman coding prevents any ambiguity in the decoding process using the concept of prefix code, that is, a code associated with characters should not be present in the prefix of any other code. The tree created helps in maintaining the property. Now let's understand with an example. I hope the above line are clear to you. Can prefix code. Step 1 is calculate the frequency of each character in the string. So पहले step में we have to create frequency or we have to find frequency of each character in the given string. So here you can see frequency of B is 1, for C is 6, for A 5 and D 3. In second step, sort the characters in increasing order of the frequency. I hope you are in graduation, you might understand increasing order. If you are not, I am here to explain. Frequency order of means increasing order. Increasing order means 1, 3, 5, 6. Are you getting any common thing? Yeah, we are getting a common thing. They are in the increasing form. So this is called increasing order. If you know, don't mind. These are stored in a priority queue. I'm not going to explain what is priority queue. Just understand there a queue, there is a form of queue is called priority queue. So this string will be stored in priority queue. If you see here, we can see B, D, A, C in different order. That is called increasing order in the form of frequency. In third step, make each unique character as leaf node. This says the characters which we have sorted, make everyone as a leaf node. Leaf node is the point where tree can't be further divided. In fourth step, create an empty node Z. Assign the minimum frequency to the left child of Z and assign the second minimum frequency to the right child of Z. Set the value of Z as the sum of the above two minimum frequencies. In this example, you can see we have 4 and the right one is 1 and left one is 3. Their sum is 4, B and D. In fifth step, remove these two minimum frequencies from Q and add the sum into the list of frequencies. In sixth step, insert the node Z into the tree. In seventh step, we have to repeat the steps 3 to 5 for all the characters, and in this way the given string has encoded in the form of tree. These two images show how the tree formed. See, 6, 9, 15, 4, 5, 9, 1, 3, 4, 5, 4, 9, 1, 3, 4. Again the same thing with the images. Now, for each non-leaf node, assign 0 to the left, this one is left, and 1 to the right edge, this one is right. Just understand by your left hand, right hand, assign 0 to the left side and non-0 1 to the right side. Now finally, for sending the above string over a network, we have to send the tree as well as above compressed code. The total size is given by this character. See, total size of character, what it is, 32. Total frequency size 15 bits. Total size of code 28 bits. Let's see for particular character. For A only 10, for B 6, for C 6, for D 9. Earlier it was 120 as we saw in first step. Now it has been reduced to 75. So this line says, without encoding, the size of the string was 120 bits. After encoding, the size is reduced to 75. So this is the advantage of Huffman. Now, when the message is sent, it's time for decoding the message. For decoding the code, we can take the code and transfer through the tree to find the character. Transfers means for each we have to visit to each character. Let's 101 is to be decoded. We can transfer from the root. This is root. Where is my cursor? This is root in the figure. We have understood what is encoding, what is decoding. Now we have to understand Huffman coding complexity. The time complexity for encoding each unique character based on its frequency theta n log n. Extracting minimum frequency from the priority queue takes place 2 into n minus 1 times, and its complexity is theta n log n. Thus, overall complexity is theta n log n. If you are intelligent, you do not have to remember. If you are not intelligent, just average boy, you have to remember. And I hope God mercy on you for your future. What is Huffman coding applications? Huffman coding is used in conventional compression formats like GZIP, BZIP2, etc. And you will understand this thing very easily. For text and fax transmission it is used. Finally, I have completed the PPT. So guys, thank you for listening me. Also for not taking interest, I would like to thank my teachers, Neha Gargman correctly, and my lab instructor Vijay Kumar Yadav sir. Thank you sir, and my batchmates, my college mates, and my college Bennett University, not Ben 10. Thank you.